All right, let's talk about something you use every single second you're on a computer, but probably never think about. We're going to pull back the curtain on the silent hero of your digital life, the operating system.
You know that feeling, right? You're deep in a game, you've got music blasting, maybe a chat window open with your friends, and somehow it all just works. It's seamless. It honestly feels a bit like magic, doesn't it?
So what's the secret? I mean, really, how can one machine possibly juggle all that stuff at once without just crashing? Who or what is conducting this crazy digital orchestra?
Well, that's what we're here to talk about. The answer is an invisible conductor, running the whole show from behind the scenes. It's your operating system, or OS for short. Think of it as the ultimate translator. You click an icon, and the OS is the thing that turns that simple click into a language your computer's actual hardware, the processor, the memory, all the guts, can understand and act on.
And to really get why this is so huge, just imagine a world without an OS. Want to print a file? Okay, great. Now you have to sit down and write a complex piece of code every single time. It's a nightmare. With an OS, you just click print. That's it. What a lifesaver.
And that really gets to the core of what an OS does. Its main goal is to be so good at its job that you don't even know it's there. It provides such a nice, clean interface that you never have to feel the messy, complicated stuff happening with the hardware underneath. You just use your computer.
So, okay, what's the mission here? What is an OS actually trying to do? Well, it turns out every single OS is trying to balance two big goals. And sometimes these goals are actually in conflict with each other.
On one hand, you've got convenience. This is all about making the computer easy to use, just intuitive. Click here, drag that, no problem. On the other hand, you've got throughput. This is pure, raw speed. How many tasks can we cram through this machine as fast as humanly possible? So yeah, it's this constant battle, easy versus fast.
And you can totally see this battle playing out in the real world. Think about Windows. For decades, it dominated the market because it went all in on convenience. It made computers friendly for, everyone. But then, for certain jobs, people needed more horsepower. They needed that raw throughput. And that's where something like Linux comes in. It's not always the easiest to use, but man, it's built for speed and efficiency.
So, how does the OS pull this off? How does it try to be both easy and fast? Well, it has a playbook, a set of key jobs it's always doing in the background.
Basically, the OS is the ultimate manager. It's juggling 5 really important things all the time. Your resources, your processes, all your storage, your computer's memory, and of course, security and privacy. So let's dive into each one.
First up, resource management. Your OS is like a resource governor. Think about it. You only have one printer, right? What happens if 2 different programs try to print at the exact same time? Chaos. Well, the OS steps in like a bouncer at a club and says, all right, one at a time. It makes a nice, orderly line and decides who gets to use the hardware and for how long. Next, there's process management. Every single app you have open, your game, your music, your browser, is a process, and they're all screaming for the CPU's attention. The OS acts like a traffic cop at the world's busiest intersection. It uses something called CPU scheduling to give each process a tiny, tiny slice of processor time, switching between them thousands of times a second. It happens so incredibly fast that, to you, it looks like everything's running at once. That's the magic trick behind multitasking. Then you've got storage management. When you save a file, you don't have to think about where on the physical hard drive it's going. Thank goodness, right? The OS handles all of that. It uses a file system, which is basically a super organized digital librarian. It knows exactly where every single piece of data is, down to the track and sector, and can grab it for you in a split second.
Okay, now for a really critical one, memory management. Your computer's RAM is like its desk space. It's where it puts everything it's actively working on. It's super fast, but it's also limited. You can't fit everything on your desk at once, right? So the OS has the huge job of deciding what gets to be on the desk, giving programs the space they need, and, this is key, clearing stuff off the second it's done to make room for the next thing.
And this is happening constantly. A program needs to run, so wham, the OS puts it into RAM. The program finishes its little job, the OS immediately boots it out and deallocates that space. And then the next process in line gets to jump in. This constant swapping in and out is what keeps your computer feeling snappy and responsive. And finally, we have security and privacy. The OS is your digital bodyguard. It's the thing that demands a password, but it's also doing something really clever under the hood.
While all your programs are sharing that RAM, that disk space we talked about, the OS builds these invisible virtual walls between them. That's what stops your game from being able to peek over and see what's happening in your banking app. It keeps everything in its own little sandbox, safe and sound.
So you start to see the bigger picture here, right? The OS isn't just another program on your computer. It's your silent partner. It's involved in literally everything you do. Think about this. Every time you do something simple, like double-clicking a file, you're actually kicking off a chain reaction. That simple click triggers what's called a system call, and that's your OS jumping into action, translating your click into a bunch of hardcore commands the hardware understands. Commands like open, read, write. It's doing all the heavy lifting for you.
So at the end of the day, that's the crucial point. The operating system is that invisible conductor we talked about at the start. It's standing there, silently, orchestrating this entire incredible symphony of hardware and software that's happening inside your device every second.
And this system has been working great for decades. But now, with AI getting baked into everything, you have to wonder, right? What new tricks will this silent hero have to learn? What new jobs is the operating system going to have to take on in a world run by AI? It's something to think about.